Today we'll talk about inferences from two samples. If we want to compare two independent simple random samples with these conditions, and we want to find out whether or not their proportions are different or equal or greater or less than each other, we have to use this test statistic and plug in all these formulae and compare them with respect to the z-critical. Let's go to an example. Now we have a table and we want to find out test at 0.05 significance level, alpha 0.05, the claim that the proportion of African American drivers are stopped by the police a lot more than the proportion of white drivers. The data we have is 24 of them stopped out of 200 versus 147 Caucasian drivers out of 1,400. And you first calculate the percent, which is 24 over 200, and this one is 10.5 over 100. But I want to find out this claim that P1, this column, is greater than P2. And at first it looks like it is. And I want to find out that at 95% confidence level. Now if you were to do this using a scientific calculator, you would have had to calculate P hat and plug in all these values and subtract from 1 to get to Q hat. These are your measured values, and put all this stuff inside this whole big formula and get 0.64. Now I know that it is a right tail test and my z-critical is 1.645. If I get 0.64, I'm around here. That means I am outside the critical region. So that means we failed to reject H null. What was H null? Right here, that it's less than or equal to. Failed to reject that. We conclude that there is not sufficient evidence to support the claim that the proportion of black drivers stopped by the police is greater than the white drivers. So in other words, I cannot really rule that out. So if I were to do the same problem using my TI 8483, I would have gone to stat, test, and I would have gone to 2-prop z test right here and enter the x1, which is 24, n1, which is 200, 24, 200, and the next one is 147 out of 1,400. And to pick the null hypothesis, you have to look at H1, and that is greater than. And I would have gone and calculated. Let's pull it down. When you do that, you see that the P is going to turn out to be 0.26 and Z is 0.64 right here. And this 0.26 is way bigger than 0.05. That means we are outside the critical region. So we found out the same conclusion doing it with the calculator. If we are looking for the interval for the differences, all you have to do again is go to stat, test. This time you go and pick 2-prop z interval right here, B option. Now if you do this right after your hypothesis testing, this data will be over there already. If not, you have to re-enter it. And you pick your confidence level as 0.95 and calculate. And that will give you these numbers, negative 0.03 to 0.06. And that means it crosses the 0 somewhere in between. That means we cannot reject H null, which is the first conclusion. Or, doing this problem, you might be looking for the interval. Either way, you'll be getting the answer. Now let's assume I'm comparing two means, and they're independent samples. Both are large, and this is the criteria. This is the test statistic I would have used. Now, if I want to do a real problem, I would have been given a table like this, and we are trying to figure out at 0.05 significance level to test. We are claiming that the distances obtained from Maguire's hits versus Bond's are different. So we put that in H1. Mu1 is not equal to mu2. That's the claim. Here's our level. And H null is mu1 equals mu2. Now, if you were to use the formula, it's a two-tailed test. You would have put in all these numbers in and gotten 2.273 that you need to compare against your critical numbers, negative 1.994 and positive 1.994. This 2.27 will be around here. That means you will be inside the critical region. You'll end up rejecting H null. Let's word this. What was H null to start with? That they are the same. So if I'm rejecting H null, there is significance evidence to support the claim that there's a difference between the mean home run distances by these two gentlemen. Now, if I go and do this in my graphing calculator, I would have gone to Stat, Test. This time you will go and you do two-sample t-test, which is number 4. Now you would have gone and gotten the stats. And x1 bar, let me go in there and enter that. That's 418, 418.5. Sx is 45.5. N1 is simply 70. Then the mean of my second one is simply 403.7. And Sx2, that one is the standard deviation of 30.6. And we're talking about 73 data points. And if you are picking this line, you have to look at this one. So it's a two-tailed test, not equal to. And assume it's not pooled. You can do an F-test to find out whether or not they're not pooled. And calculate. When you do that, you simply go and get the p-value, which is 0.02, and you compare this to your alpha, which is 0.05. You end up in the critical region, which is the same conclusion you would have gotten if you did it using a scientific calculator. Now let's assume I want to find the interval for the differences in the mean. So to be able to do that, you go to Stat and Test. Now this time you are doing two-sample t-interval. Right here, 0. And push that. If you are doing this right after the hypothesis testing, these numbers would have been just there. So let me double check. So for 18.5, 45.5, 70, and this one, if you look at it, these are all entered for us. And all you have to do is enter the confidence level of 0.95. Assume it's not pooled. If you're not sure, do the F test and calculate. When you do that, you simply get the number 1.9075 to 27.692. And it doesn't contain the 0. That means you reject H null, which is the first conclusion that we arrived. Now the last one that I'll cover is if you are doing some kind of hypothesis testing using matched pairs, this is the test statistic you would have used. And then you would have calculated the d hat and the population of the differences assumed to be 0, because you would have formulated your problem in that way. So let's look at an example. We have 5 actual low temperatures and predicted low temperatures, and they are matched. So that's the data that consists of matched pairs, and they are the same day readings, predicted and actual. I want to use 0.05 to test the claim that there is a difference between the actual low and the ones that are forecast five days earlier. So what I need to do is I need to enter that data in my calculator, and I did that for you. You go to Stat Edit. If you look at L1, I entered the actual lows, 1, -5, -5, 23, 9. In L2, I put the forecast values. In L3, what I did, I just subtracted this line, this minus that. So to get that, you push enter and you put L1 minus L2 while you're in that line. And that will give you the differences right here. Now, since you have that column, what you need to do, if you were to do it by hand, this is how you would have set up your H null and H1. And this is your claim. The differences are not 0. Then you would have put in the D hat. And how do you get that one, -13.2? You need to do a one variable statistics on L3, and I'll show you this value turns out to be -13/2. So if you were to do that, you go to Stat, calculate one variable statistics on L3, and as you see, you get -13.2. And now you plug that in, and you get -2.76, and you compare this to your t-critical that you get from the tables, and you find out this is outside the critical region. That means you don't reject H null. And here's your critical value from the tables. The thing is, if I were to do this using my TI-84, I would have gone to Stat, Test, and this one says L1, but I put the differences in L3 in the calculator. So you go the Stat Test, and you have to get the t-test. And ignore L1 and L2, and you're doing the data now. So you have to go get the data column. And I put this one is what's in your hypothesis testing, which is 0. And you tell the calculator the differences are in L3. If it's in L1, you put L1. And you put not equal to, which comes from the H1. And all you have to do is go calculate. When you do this, you see the p-value is going to be 0.0507. It's barely greater than 0.05, but nevertheless, it is greater. You are outside the critical region, so there is not sufficient evidence to support the claim that actual and 5-day forecast temperatures are different. Now, if I want to do the interval for the differences, all I have to do is Stat. You can use the big lengthy formulas, but I'll use the calculator, Stat Test. And it says L1, you can put in L1, but I put it in L3 at this point. I will go and I will do the t interval, and I will say that the differences are in L3. You put that in there. All you have to do is put the confidence level 0.95 and push calculate. And they will give you the answers in the interval notation, -26.47 to 0.06897. And this does contain the 0. that means you do not reject H null, or you are just asked to get the interval. And this concludes the portion of the lecture about two-sample hypothesis testing and the intervals.